Righty, we're on. Any thoughts about anything? Guys doing okay with material? I just looked at the schedule and we're pretty much on track, amazingly enough, given that I just make up the schedule. We're supposed to finish and or not today, and we may or may not, but we'll be close. I looked, the test isn't for a couple of weeks, so we're doing okay. I don't have to start thinking about it yet. Any thoughts or concerns? Very good. Or yes.
Can you give us a line of what's going to be on the test so we can send you?
Well, the web page already outlines the topics. The first page of the PowerPoint outlines the topics, and what's going to be on the test is everything up until the class or two before. And yeah, you can see on the schedule there, if you go to dates, right, it says when the test is, and we're going to finish and or not today, and then we're going to start up with for all that exists. All right. And yeah. All right. So this page is talking about proof by generalization. And that just means if you have more than one case and there's symmetry in the cases, then you don't have to do both cases. You just say by symmetry, right? So you have to prove it's true for all cases. You know, for a tautology, it's true in all situations. So in all cases, and two cases are the same except symmetry. You say without loss of generality. So here's just a quick example I made up. There's an equation for computing the minimum, and there's symmetry between x and y, right? You see, everything in the statement that we're trying to prove is symmetric if you swap x and y. So we don't know which is bigger, x or y, but we might as well say that x is bigger. Why? Because if y was bigger, you would swap them, right? That's all we've got to say about that. How are people feeling about this purple table? People feel it's kind of intuitive? All right, so those of you, particularly the non-head shakers, right? Let's just throw them all up on the board. And seriously, don't be ashamed if there's one that doesn't resonate with you in your heart. Let's chat about it and see if you can, get online. All right. So again, how's the table organized? Here are the three key operations that we're dealing with. And remember, we start with axioms, and I'm going to tell you what you're supposed to prove, right? So we start with stuff here and stuff here, and you can work in either direction, right? And the side on the left says, if you know it and you want to use it, and the side on the right says, if you want to prove it, what do you need to prove it? Right? And it's good to work in, yeah, as I say. And then from conclude means on the from side, you've proved these already. And then the conclude side is hence this can be a line of your proof, right? So on the proof side, it's kind of opposite. The conclude side is what you're trying to prove, and the from side is what you need, what you're building up, right? And he was asking what's on the test, and last test, I put this, what you see right now, on a piece of paper and asked you to fill in as much as you could. All right? And I don't remember how people did on it, quite frankly. All right, so, I mean, you say, oh, I have to memorize it, right? Yeah, but it's pretty straightforward. How do you want to use an and? If you know the and of two things are true, then they're each true, right? Come on, that wasn't hard. This side might be a little harder. How do you prove the and? Well, you have to prove both of them, right? If you prove alpha and, you prove beta, right? If you prove that alpha is not true, then the and's not true, right? If you prove alpha is true, then what's left to prove the and is proving the beta, right? Can everybody read that? Right? Selecting or, if you know one of them's true and you find out that alpha is not true, then that leaves you with beta being true, right? Similar building rules. If you know one of them's true, then the and's true. To prove that we're doing or. If you prove one of them's true, then the or is true, right? To prove the or is false, both of them have to be false, right? In fact, maybe this will just confuse you, but we're at some point in this course, we're going to get to this idea of duality, right? Duality is good and evil, right? You have two sides, opposite sides of the coin, which in some sense, infinity plus infinity come around to minus infinity, right? One thing about and or is if you flip all the ands to ors and you flip all your variables to not variables, true or false, then everything sort of becomes the same again. But so here it's just, see this rule here and this rule here are what I call duals of each other, right? If I tell you that alpha is not true, then whether the or is true comes down to whether beta is true, right? Proof by cases, right? You all know proof by cases. I have a bunch of cases. I know that these cases cover all situations. Why? Because the or of them is true. Means at least one of these cases is true, and I don't know which. So I'm going to handle each of these cases separately. For each case, I say, if I know this is the case, right? And I like to pretend that, some oracle assures me of it, or some little bird tells me it. So I know that we're in this case, right? And then from that, you prove what you want. And then if you handle all cases, you get everything. And of course, why is this cases in two places? Well, it's how to use an or, and it's how to use an implies, right? Excluded middle tells you it's just stuck in here. I guess it's under or. It's how you prove an or, right? It's yeah.
By cases, you're wanting to ensure that you're encompassing the whole universe to ensure that.
Yeah. I use universes different than you. I think you're talking about the universe. I mean, if we want to prove something is true for all animals, then you have to prove it for each animal in the universe.
Yeah, so like given the
Yeah.
axioms that we
Yeah.
have, like say whatever question.
Yeah,
based
exactly.
on that.
Exactly. I often use universe being there are many universes and you have to prove it for each of them. So it's slightly different definition of universe, but that's okay. Excluded middle is two things can't be both true, and at least one of them's true. It's not true that they're both true, right? Modus ponens is how you use the imply, right? If somebody tells you that alpha implies beta and you know alpha is true, then you get beta, right? Deduction is how you prove alpha. There are two cases. Alpha is true and alpha is not true. If alpha is not true, the implies is automatically true, right? So let's pretend we're doing the case where alpha is true. You assume alpha is true. You indent. You're now being assured by your oracle that alpha is true. And you go off and prove beta. And then you pop out of the indent where you no longer is assuming alpha, right? And you don't know whether alpha is true, but now you know that alpha implies beta, right? How do you, the building things, right? If alpha is false, you know, the input you get doesn't meet the precondition, then it doesn't matter what the postcondition is, right? If beta is true, right? If your program does what it's supposed to do, it doesn't matter whether the input meets the precondition or not, right? And the only time you get the implies false is if you know alpha is true and beta is false, right? Simplify. If alpha is true, then we need beta to be true for it to be true, right? And if beta is false, this is the funny one. When beta is false, then we need, for it to be true, we need alpha to be false, right? It flips. If and only if alpha implies beta, beta implies alpha. Counter positive. All right, these ones are good to know. If alpha implies beta and beta is not true, then alpha can't be true, right? Because if alpha was true, beta was true. So what are we doing is we're switching the directions of the implies and we're changing true to false, right? Which, quite frankly, goes back to my idea of dualism, right? You're flipping true and false. You're flipping the directions of arrows. Everything flips and it becomes true again, right? Oh, and then you can write this one either as an or as an and, right? This one says, why is this true? Well, because we either make it, you know, if we set alpha to be true, if we set alpha to be false, it's automatically true. If we set beta to be true, it's automatically true. And if one of those is true, then it's true. And if neither of those are true, then it's false, right? And then you can switch this. Remember, you can switch the, right? This is not alpha or beta. Well, you can bring the negation on the outside and you get, right, if alpha is true and beta is false, right, then it can't be true. Right, everybody remember that? So that's just using, maybe we don't have it written down yet. All right, transitivity. Right? If I can get from A to B and I can get from B to C, then I can get from A to C. Right? Here's the one I just said. It's taking the dual. It's you flip the true false on the outside, you trip the true false on the inside, you switch the and to the or, right? It's the dual. You bring the negation in, it flips the and to the or and the or to the and. Right? Double negation, commutative and associative. Commutative means you can switch the order. Associative is you can flip the order of the brackets, which I don't think I wrote down. The distributive is a little confusing one, but don't panic too much because I'm not going to let you use it. Right? So you should know it. Why don't we want to use it? Because it doubles the size of what you're working with. And if you double it n times, then that's big, right? Proof by contradiction. Students always want to prove things by contradiction. I don't know why. And you got to make a good argument to me to why it's better than just doing it directly, right? But here's a little kind of funny one that we're going to cover in 15 minutes or so. It says, once you've got a contradiction, once you prove, say, both beta and not beta are true, then you're kind of in no universe, right? The whole world collapses. And once the whole world collapses, everything becomes true. I mean, when I say everything, it's the sky is blue is true, and the sky is not blue is also true, right? Everything collapses. All right. On the last test, remember when they had to fill in the table? I also made them give a little explanation as to why each rule was true. And this is the solution set. So you can read it. You can read it. It's I think more or less it's what I just said. Oh, and this is how to satisfy things, right? You substitute in values, and then I don't know, you simplify it. Oh, this kind of looks like Davis Putnam. Remember, you don't have to remember his name is Davis Putnam, but it's let's call it the game of 20 questions, right? Where you have a tree of possibilities and then you prune it because you get things, right? Here we started with some statement. In fact, it looks awfully like the father thing, right? And then you branch. Remember we had what we did in the slides. This is now in the slides. I guess maybe when I put this on the test, it wasn't in the slides yet. Right? You can branch on it being false or true and so forth.